Hello guys, my name is Diego Pacheco and this is another Java video. So this will be the second video about Monorepo and Java. So on the first video I was talking about Bazel from Google, and today we're gonna talk about Buck from Facebook. So Buck was created in 2013, so it's 2 years old than Bazel, and basically is used by Facebook. Buck is also used for Monorepos, and you can use to build Android, iOS, Java, .NET, Go, Rust, Scala, Python, and I made some simple monorepo solution with Java. I want to show you guys so you can compare with Bazel. It's really similar. If you want to know more, you can go buck.build, and let's get started. So I have a simple monorepo here I made with Buck. So I also, this is very similar to the Bazel structure. I basically did Bazel and I copy and paste here, so you guys would have no issues comparing both. So if you watch the other video about Bazel, it will be very easy to compare with Buck, and you're gonna see they are pretty similar. I found that Buck support is a bit more up to date, both with IDEA and VS Code, but we're gonna be using VS Code on this video as well. So let me show what we have here. There's some differences from Bazel, and I'm gonna highlight that. But first, let's look at the project structure. So I have 3 projects here, project A, B, C. So if I take a look on project A, I have similar Maven and Gradle structure with SRC main Java and SRC main tests. SRC tests, actually, not Java. And I have a class here called compare utils, where I basically use Google Guava as dependency. Then I have another project called project B. This project does not have dependencies. I just wrote a sort of a custom logger where you pass a string, I'm logging. That's what I got pretty much. Now, let's take a look on the third project. So I have a project called project C, right? And in this project C, this is interesting because this project C is where I'm doing the orchestration between project A and project B. So I'm using both projects here, right? So there is an app with a main class, and also there's a test here, right? So let's take a look on this on VS Code. So this is project A. Let's take a look on the compare utils. So here basically using Guava to do some comparison between 2 numbers that came from parameter. That's pretty much it from project A. For project B, I have my logger, right, where I receive a message. I'm using the standard Java util class to print the date, you printing this character and whatever the message is. And for project C is where we have something a bit more interesting, where we are using all these things together, right? So as you can see, I'm importing compare utils from project A, custom logger from project B, and I'm making a compare function here where I'm passing to compare 2 and 2, and also I am instantiating my app and logging the result here. This project has a test, right? So if you could take a look here, and then this test is a JUnit test, as you can see, at test here, importing assert, right? And then I'm calling assert equals, comparing, this will do compare between 2 and 2, so it should be 0. So that's the project we got here. So now I'm gonna build this so you can see Buck in action. So there is a command called Buck needs Java 8, right? So there's a command called Buck you're gonna run. So first we're gonna do Buck build, and what we're gonna build is project C, all right? So you can see this was lightning fast, and the reason it was so fast was because I was building before, right? So there is a cache going on here, but we can do Buck clean to get rid of the cache and start a new instance of the daemon. And now if we build it, you're gonna see doing things, all right, and it does things in parallel. You can see here that's complaining, all right, that by default fetching files at runtime was disabled, right, because they make the build slow. So what you want to do is to run buck fetch, right, and then you can fetch the dependencies, and we'll do all this in parallel, right? So we fetch the dependencies, and you also can fetch the dependencies for your tests. They also can be done here. Then once we do that, then we can do buck build, right? And there we go. Now we are building the project. So we see it took 1.8 seconds, but if we do go again, then it's 0.0. So pretty fast, and the cache kicks in. So if we run, we just do buck run and the name of the project. So we're gonna run project C here, right? And you can see here the output. We also can do tests if we basically do buck test, and then we can pass the test project, right? So it's tests, and then we run the tests. So we can see here we run one test. I prefer a bit more the buck test runner. I think this is a bit more visual, more useful than Bazel test runner. I found a bit better. But yeah, we just run the tests and we just build it. So now let's take a look how you do with buck. So one big difference is you need a file called .buckconfig. That's the first file you need to have there. Even if you don't have any content on there, you need to create this file. Otherwise, you cannot really use buck, right? So there are some important things here. So in Java, I'm setting some default rules like the root source in Java's are Java, resources, and src. And also I'm saying that by default Java is on Java 8. I'm saying I want to use this Maven repository, which is Maven 2, the default Maven repository. I found this a bit annoying on buck. If you don't pass this configuration here, you're not able to get any jars, because by default it doesn't know where to get the jars from. So you really need to add this file here. I found this a bit annoying. And another thing you need to do, you might need to do some definitions, right? So when I was commenting about ant similarities with Bazel, here in buck we have the same deal. It's really similar to ant if you think this through, right? So there is this includes. You can include a file that include other files as well, right? But I'm doing with one file. So I defined it in a file called root.defs. So we need to take a look on that file now. So if you take a look here, there's a file called root.defs. And then here, this will not make sense now, right? But will make sense soon. There's some definitions, all right? And these definitions basically say how we're gonna get a Maven jar. And again, this does not come by default. In that sense, I prefer Bazel. I found much better. So what you do here, we're saying how we're gonna get the jars, and we actually gonna use remote files, right, which gonna be in Maven layout. Here we need to pass the bin SHA-1 for the binary for the jar, and also the SHA-1 for the source code. If you go npm repository.com and you click on files, you're gonna be able to get that information, right? But often folks doesn't care about that. Often it's just group ID, artifact ID, and versioning. Of course, passing these two things make it much more secure and avoid tampering, right? So security definitely gonna like this. But for developers, you need to add two other things that often we don't add at all, right? So with that, now we can go to the build, right? So there's a file called buck, similar to Bazel, right? So instead of the file called build in Bazel, in buck it's called buck. And it's really similar. It's almost the same, right? So we're gonna define Java libraries, but now as you can see, we don't need any loads, right? We can go straight adding Java libraries, and then you have a name, src. I'm just I don't need this, but I'm defining so you guys can see the source code and the target code, and also dependencies. Dependencies are a bit different in buck, so you can see this lib guava, and we're gonna look this very soon. Then is really similar than Buck, than Bazel. One different thing I'm doing here is I'm using this, right? So I don't need to put all the package, right? So it's a bit shortened, right? And then, this is project A and this is project B. And as you can see, project B doesn't have dependencies, and then we have project C. So project C, we have project A and B as dependency, and also we need to add JUnity in order to run the tests. And then there's the Java binary, similar than in Bazel, right? But here, instead of runtime steps, is always steps. So I think it's more consistent for Buck. And then we have a Java tests where we have the SRC. We can use testng or JUnit, by default JUnit, but I'm showing how you can override it. And then the dependencies. We really need to add JUnit in Humcrest, even if your code do not use Humcrest, but Buck need it. So I found this a bit annoying, but it is what it is. And then we have like the three projects, A, B, and C here, right? And that's the build file. So one thing I need to show you guys is how we handle the libs. So I have this lib folder when there's another Buck file here. And here we use Maven jar to define Guava JUnit in Humcrest, all right? And that's how we do it. We basically have the artifact group ID, artifact ID version, binary SHA-1, and source code SHA-1. And you cannot make this up; it will not work. All right. So you need to go from nvm repository and copy that SHA-1's there and paste it here. And basically, that's what you do, and that's how you roll with Buck. So that's it for this video. I hope you guys like it. See you next time. Take care. Cheers.